Very good. Let's get started, guys. So, today we're working on what's called second derivatives, and as its name suggests, that just means you're differentiating something twice. Okay, so when we have dy on dx or f dash of x, that's the first derivative. If we differentiate it again, we get what's called the second derivative. So, let's get straight into it. First, I'm going to express this as a single power of n, that is x to the power of a third. Alright, now it's ready for me to differentiate. So I will go dy on dx is a third x to the power of minus 2/3. Alright, so we should be getting pretty good at just cranking out those fractions and operations in our head. A third take away 1 minus 2/3. Okay, so then for us to find the second derivative, right, for us to differentiate it again, this number out in front is just a multiple, so that's just going to stay there. Alright, now the way we communicate the second derivative, if we're given y, we have dy on dx, and we have d squared y on dx squared. Alright, that means the second derivative. And I've said the third is just going to hang out, that's a number, 0.3 recurring. And so I'll open a bracket and we're just looking at this component, x to the minus 2 on 3, and we're just going to apply the power rule. Alright, so it's x to the n, it becomes n x to the power of n take 1. So I might do this one, minus 2 on 3 take 1, and let's evaluate that. Alright, if you have minus 2/3 take away 1, we need them to have the same denominator, so it's minus 2/3 take away 3 on 3. Minus 2 take 3 is minus 5 on 3. Alright, so our second derivative is, and maybe I'll perform this fraction operation as well. Let's perform a little bit of simplification. We have 1 times 2 at the top, so that's going to be 2. And we have 3 times 3 at the bottom, so that's going to be 9. And we have a positive times a negative. So the whole fraction, the value that it evaluates to is going to be negative. And then we have this x to the power of minus 5 on 3. Alright, so there we are. We've evaluated that one. That's what we call the second derivative. Now notice I'm clear with my notation. We've got y, this is the function. We've got the first derivative, and then we've got the second derivative, and it's still equal to the second derivative. We've maintained. Probably going to change anything. So make sure you're clear with your notation. Remember, I've seen students in the past, they just write equals, 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 equals. That's not equal to that. Okay? We've performed an operation, we've differentiated it. So you must make sure to show that. Okay, this is a good question because this one, you would look at that and hopefully if you've been keeping track of the rules, you would say, yep, we're going to use the quotient rule there. Okay? And you could do that. Okay, you could use the quotient rule and we'd perform it. And we'd have u dash, v dash and smash it all together. But then, in order to find the second derivative, we would need to use the quotient rule again. Why? Because the quotient rule is always going to have a function as the denominator. Alright, and so that just seems like a long, tedious way of doing it. We always want to look for the fastest way of doing it. It would get you full marks. You'd still get full marks because you're just asked to differentiate it. It's just going to take a lot longer. So we're looking at this and going, what's the fastest way for me to simplify it? And the answer is going to be using index laws. First, we're going to split the denominator, and then we're going to use index laws to simplify it. So if I split the denominator here, what's going on is we're going to write it like this. X squared on the square root of x, take away 3x on the square root of x. So the only time we're going to split the denominator, there's sort of 2 caveats that we need. The first is that there's only one term at the bottom, and the second is that everything in the function is x to the power of m. Okay, here we've got x squared, here we've got x to the power of 1, here we've got x to the power of half. So if it involves sine or ln or cos or tan, we can't split the denominator to differentiate. Okay, so then what I'm going to do, I'm just going to still maintain equality and represent it as, that's a tape, represent it as powers of n, so that now we can simplify it using index laws. All right, so we have the same base, So then it becomes the top power, take away the bottom power. And over here, the 3 is just hanging out. The 3 is just a number that we're multiplying the variable by, and we're going to have x to the 1 take a half. All right, so I'm really doing this in an excruciating amount of detail. This is minus 3 on 2. This is positive half. And notice the equals. This is all the same function. If you graph this, and you graph this, and you graph this, and you graph this, and you graph, they're all going to look exactly the same. They're the same function, different ways of writing it. But the point is, now we've got it in a form ready for us to differentiate in one step. Let's go. F dash of x, we're going to have minus 3 on 2 x to the minus 5 on 2.
Okay, so what if the x squared take off? Wouldn't that be like a
Positive 3 on 2, yeah, thank you. So that's going to be half. Yeah, so 2 take a half is 1.5, 3 on 2. And then 3 on 2, x to the 3 on 2 take 1. I'll write that out, 3 on 2 take 1. Okay, so in the next step, I'll show you what we've got. 3 on 2, half, take 3 on 2, x to the minus half. Okay, so that's the first derivative, and then for the second derivative, all right, so when we've got f of x, we use f dash, and then f double dash, f dash dash. All right, so f dash dash of x, and the numbers are just hanging out the front. X to the half is half x to the minus half. Here we have 3 on 2, that's hanging out, minus half x to the minus 3 on 2. And we'll leave our answer like that rather than simplifying it again. Alright, so once we had it in a form ready to differentiate, look, and I did all of these steps, like, you don't need to show all of those steps. You can go from there, show that you've split the denominator, and then show what it evaluates to. So you can miss sort of 2 of those steps and still communicate that very clearly. Anything else to say about that one? Only, like in the book, right, when they're simplifying them in the textbook, alright, you should remember x to the minus half, that means 1 on top of the square root of x. X to the minus 3 on 2, that means x on x root x, 1 on top of x root x. So that's what they can evaluate to, they can simplify to that. Alright, let's move on to the next one. We have cos of e to the x. We have cos of some function. So we're going to use our trig rules that we learnt last time. When we differentiate cos, it goes to negative f of x, f dash of x, sine of f of x. So I'm looking there, our function is e to the x. When I differentiate e to the x, I get e to the x. So I've got negative e to the x, sine of e to the x. So when we differentiate cos of f of x, negative f dash of x, sine f of x. Alright, so that's the first derivative. For the second derivative though, if we're looking at it, we've got e to the x times by sine of e to the x. So we need to use the product rule. So we'll have u is minus e to the x, u dash minus e to the x, v sine of e to the x, and v dash, when you differentiate positive sign, it goes to f dash of x cos of f of x. Alright, so when I'm reflecting on that, we're not really doing anything new other than differentiating again. We've learned all of these rules before. And so now we just smash it together to get the second derivative. D squared y on dx squared, u dash v plus u v dash. And now, when you're required to solve those kinds of things equal to 0, you're looking along, you're going, what's a common factor? Hopefully you're looking at that going, you know, even before you're moving on to the next step, you can see e to the x is common. Okay, we could pull it out in front. All right, let's move on to 2. So here we have some quadratic. We don't know this quadratic, but we are told these other pieces of information about it, and we're just going to use all 3 of those pieces of information to determine the values of a, b, and c. So firstly, f of 0 is 3. That means when we put 0 into this function, it evaluates to 3. All right, so you can look at that. If I put 0 there and 0 there, I'll write it out. We're going to have 3 equals a times 0 squared plus b times 0 plus c. All right, so I'm putting x is 0 in. The y value is 3. And what are we left with? 3 equals c. All right, so we've determined the value of c. Let's use the next piece of information. It says f dash of 2 is minus 5. That means we need the first derivative. All right, so in the book, does it say y or does it say f of x? Y. All right, so I should fix that. I'm just going to change it to f of x because we've written these out in terms of f. All right, so if I'm going to find f dash of x, and you can differentiate this even though you don't know the values of a and b and c. All right, a is some number, so when you differentiate ax squared, we're going to get 2ax. All right, same rule applies. It's some value, we don't know what it is. And when you differentiate bx, it just is b. All right, derivative of kx is k. And derivative of c disappears, that's gone. So we've got 2ax plus b, and we're told when you put 2 in, it equals minus 5. All right, so we're going to put the number 2 in where the x is, and it's going to equal minus 5. And so here we've got an equation. We've got 4a plus b is equal to minus 5, but we don't know what the value of a or b is yet, so we can't solve that. We need to use another piece of information. We're going to have to leave that for now. All right, so that's one of the equations that we've got that we'll come back to. So let's use the next piece of information then, which is that the second derivative equals minus 4. So this is our first derivative. So if we're going to evaluate the second derivative then, all right, what's the derivative of 2ax? It's just going to be 2a. B is a number, that's disappeared. And we've got the second derivative equals minus 4. And so therefore a is minus 2. All right, we've determined the value of a. So we're going to go back into the equation we developed up here to determine the value of b. I'm going to put that a value right there. So I've got minus 5 is 4 times minus 2 plus b. Minus 5 is minus 8 plus b. b is 3. Alright, so we've determined the values of b, a, and c. We solved for the quadratic, given the information we're presented with. Okay, so look, to start this lesson, I would like us just to work on this exercise. If you finished it, then you start revision. But I want to have a big class discussion, either today or in our next lesson, about the direction we're going to take with revision. So proceed with where you're up to. I'll come around and see how we're going, and we may have that discussion today. We may have it on our next lesson tomorrow.